Welcome to Proactive Air Services. In this episode, we are going to talk about the engine of an aircraft. We've just learned about the basic parts of an airplane and how it is controlled, but it's equally as important for us to understand how the power is generated to move the airplane through the air. An airplane has an engine, which is commonly referred to as a power plant. The reason behind this name is simple. The engine not only powers the airplane to move it through the air, it also has other components attached to it in order to create electricity, vacuum suction, and heat, just to name a few. The power plant of an airplane, like an engine of a car, is one of the most important components because without it, there is no way to get the plane off the ground. Aviation engines can be separated into two groups: reciprocating engines and turbine engines. While most airlines and corporate airplanes use turbine-powered airplanes, general aviation and training aircraft are equipped with reciprocating engines with several cylinders. Inside of those cylinders, fuel and air are mixed, compressed, and then ignited. As this fuel-air mixture is ignited, its explosive force moves the piston inward. These pistons are connected to a crankshaft, and when the pistons move in and out, that causes the crankshaft to rotate. The propeller is connected to the crankshaft, so as the crankshaft rotates, so does the propeller. The cylinders undergo a continuous four-stroke cycle. The four strokes are called compression, power, and exhaust. The first stroke, the intake stroke, is when the piston inside the cylinder moves away from the cylinder head. As the piston moves away, the intake valve opens and the fuel-air mixture is sucked into the cylinder's combustion chamber. Once the piston has reached the base of the cylinder, it's time for the second compression. During this phase, the intake valve is closed and the piston reverses direction, moving back towards the cylinder head. This compresses the fuel-air mixture, since it has nowhere to escape. Once the piston approaches the top of the cylinder, we begin the third stroke. Power two spark plugs at the head of the cylinder, each let off a spark, which ignites the fuel mixture and makes it combust. This controlled explosion pushes the piston back inward towards the base of the cylinder, which in turn rotates the crankshaft and therefore the propeller. Finally, we reach the last stroke, exhaust. During this phase, the exhaust valve opens and the piston moves back towards the cylinder head, pushing out the combusted gases, commonly called exhaust. Then the process starts all over again, repeating the process thousands of times every minute. On a typical four-cylinder engine, each one of the cylinders is in the middle of a different stroke. That way one cylinder is always in the power stroke and the engine is able to keep the crankshaft rotating, thereby allowing the remaining cylinders to go through their respective stroke. As we just saw in these four strokes, there are two valves at the head of each cylinder that open and close to allow the fuel mixture in and the exhaust gases out. But what controls those valves? That would be a camshaft. The camshaft is a rotating cylinder situated above the crankshaft with various oblong lobes protruding from it. These lobes push on rods that connect to each valve, pushing them open. The valves are spring-loaded and will return to the closed position as the camshaft lobes move away from their respective rod. Getting the valves to open at the exact moment is very crucial for the engine to operate. Because of that, the camshaft is geared to the crankshaft, so they will remain synchronized. The camshaft is geared to spin half as fast as the crankshaft. This results in the valves opening twice during the four-stroke cycle. Now, how do we get the fuel and air into the cylinders? It's simple. The induction system inside of the cockpit of most general aviation aircraft. There are the throttle and mixture controls. The throttle controls the amount of fuel and air that go into the cylinders, while the mixture controls how much fuel is mixed with the air. In simple terms, the mixture controls the ratio between fuel and air. Typically, for every fuel molecule, there are 15 air molecules. The mixture adjusts the amount of fuel necessary to maintain this ratio. The throttle, on the other hand, controls how much of that ratio is let into the cylinders. The more the throttle is open, the more fuel and air enter the cylinders, and therefore the more powerful the combustion will be, making the engine run faster. The air that is part of the fuel-air mixture enters the system at the air filter usually found in the front of the airplane. Once the air passes through the filter, it is metered and sent on its way to the cylinders. Let's talk about how we get that mixture to ignite. The ignition system is what provides the spark to the mixture. The major components of the ignition system include the magnetos, the spark plugs wires, and the ignition switch. Just as its name implies, a magneto consists of a rotating magnet that generates sparks of electricity. The spark that is generated is independent of the airplane's electrical system. That means if the airplane's electrical system were to fail, the magnetos would still be able to generate sparks for the engine to run. The energy generated from the magnetos is sent to the spark plugs. The spark plugs then release that energy, which ignites the fuel-air mixture, creating power to turn the propeller. Most airplanes have 2 magnetos, multiple sets of wires, and 2 spark plugs per cylinder in order to increase efficiency and reliability of the system. If one magneto fails or one spark plug fails, the engine will still run. However, power output will be slightly reduced as the engine is operating less efficiently. We also use air to cool our engines as the airplane flies through the air. Outside air flows through inlets, usually found on the front of the airplane, like the Cessna 172. This outside air is colder than the engine, so as the air flows over the engine, it cools it in the same manner that the oil cools the engine. This method of cooling can be severely restricted. However, when the airplane is running at high power and at very low speed, such as when climbing, airflow is minimized, causing higher temperatures. The last step in the 4-stroke cycle is the exhaust. The exhaust system has a dual purpose. In most general aviation airplanes, as expected, the exhaust system does allow the hot exhaust gases in the cylinder to escape the engine in a quiet manner.